Today our topic is triangles, and we're just going to get into some definitions and just talk about the way that triangles work. So if you imagine the following triangles. So these all look very different. They're all triangles. They all have three sides. That's what defines a triangle. But these all have certain names. All triangles add up when you talk about the measure of the interior angles. That's the angles here, here, and here. When you use a protractor, here, here, and here, and here, here, and here. Whenever you add them up, the value you're going to get is going to be 180 degrees. That always works for any triangle. This one here is a type of triangle. Every angle is less than 90 degrees. I can tell that because they're smaller than this one right here. If you think about it, it's not as wide. So this one here is going to be what's called an acute triangle. Such a cute triangle. Sometimes people think about it that way because it's such a small triangle. Now this one here, it has that angle right there. That angle, that box within a triangle, within any shape, indicates that that is a 90-degree angle. A 90-degree angle within a triangle means automatically it is a right triangle. And the one down here, there's one angle, and it's this one right here, that is bigger than 90 degrees. It's wider. It's wider than this one here. So that means this one here is called an obtuse triangle. These are just definitions of words as to how we talk about triangles. So if I have a triangle here, I know that the three angles together, the 60-degree angle plus the 60-degree angle plus x is going to equal to 180 degrees, because that always works for every triangle. So if I'm going to solve for x, this is going to be 120 degrees plus x is equal to 180. Subtract 120 from both sides, you end up with x is equal to 60 degrees. So I know that 60 degrees would go up here, and I also know that this would be an acute triangle because every angle measurement is less than 90 degrees. So we can also classify triangles by their sides, what they measure. Now this triangle, the red triangle, that one there, all the sides have the same length. So it's going to be what's called an equilateral triangle. Now the blue one, you can see two sides are the same length. And so that's going to be what's called an isosceles triangle. And the green one at the bottom, none of the sides have the same length, so that's going to be called a scalene triangle. And if you notice on these, I put these little marks here. Those little marks mean all the sides are the same. These marks mean that two sides are the same and one side is different because there's two little marks on that one. And this one means all the sides are different because one has one mark, one has two marks, and one has three marks. One more little bit of review. The area of a triangle is going to be the base of the triangle. In this case here, it's going to be 3, times the height of the triangle, the perpendicular height. That's why that box is important. That means that it's a right angle. That means it goes straight up. So it's going to be 3 times 2, and then whatever that is divided by 2. So this is going to be equal to 3, and area is measured in square units, so it's going to be 3 feet squared. This one over here, if we look here, it's going to be 6 meters times 3 meters. This 3 meters again is the height, so it goes from the bottom to the top. So it's going to be 6 times 3, and then it's going to be divide by 2. So it's going to be 9 meters squared. So for this isosceles right triangle, if we were to figure out the area of it, we'd look at the base times the height divided by 2. So it's going to be 6 times 6 divided by 2. So that's going to end up being 18. It's going to be meters squared. And again, some people might be more used to this formula, 1/2 base times height. I like this one more over here. It just makes more sense to me. Divide by 2 at the end. Choose whichever one works as long as it consistently works for you.